All right, students, let's review what we have done in the Topic 8 section so far. We pretty much have learned about mean. If you remember correctly, the mean is the average of a set of data. Then we learned about the median. And when we put our data in order from least to greatest, the median lies in the middle. And if there's not a distinct middle, then we have to average the two in the middle. Okay, this should be bringing back some memory for you. And then we have mode. And mode means the piece of data or the number that shows up the most number of times. And you can have more than one mode. You can have 2 or 3 modes or 5 or 6 modes. It just depends on what the data looks like. And then we have what's called the range. And the range is just the distance from the high to the low. So it's just the high number minus the low number, or it's the maximum minus the minimum. And you need to learn those 2 words also. Now then, these 3, I'm going to draw a line through here. These 3 right here are called measures of center. Kind of tells you where the center of the data is. And this 1 right here is called a measure of variability. It's how far apart the data is from the highest to the lowest. How much variability is there in the data. Okay, and all of that was in section 8.2. Then in section 8.3, we learned how to take some data and display it in box plots. So let me make a little, and let me just move this up. So this was all in 8.2. Okay, now let's move all this up a little bit and let's talk about 8.3 when we did that section. It was all about box plots. And box plots require, you have to know 5 things to build a box plot. So we call this the 5-finger statistics. Okay, so we have to have a minimum, that's our lowest piece of data. We have to have Q1, quartile 1. We have to have Q2, which is known as the median. We have to have Q3, which is quartile 3. And we have to have a maximum. And we learn that with our fingers. We have to have a minimum, Q1, Q2 or median, Q3, and maximum. Okay, so there you have that. And this is called the 5-finger statistics. Now, when we want to put this on a graph, this is a dot, this is a line, this is a line, this is a line, and this is a dot. So we have a dot, a line, a line, a line, and a dot. That's what our fingers stand for. So we have to, when we draw our number line, these 3 make the box. These make the box. Okay? So then we'll draw a little picture of one. So let's say we had some data, and I'll just make up some numbers to use for these. This is, we'll make this 0, 10, 20, 30, 40, 50, 60, 70, 80. Let's say our minimum ended up being 20. I'll put them out to the side here. Our Q1 ended up being 35. Q2 was 40. Q3 was 60. and the maximum was 80. So 20 would be a dot. 35 would be a line. 40 would be a line. 60 would be a line. And 80 would be a dot. And then we close up the box and attach the whisker. This used to be known as box and whisker. These were your whiskers. Your book calls them box plots. Okay, so you recall that information. All right, so that leads us to today, which is lesson 8.4. So today, students, you're going to learn how to take some data and display it in frequency tables and histograms. Okay? So in the I can statement, it says we're going to make and analyze frequency tables. The word frequency means how often something happens, and histograms. Okay, so a histogram kind of looks a little bit like a bar chart, but it's a little bit different. Okay, so the students in 6th grade class recorded the number of letters in their first and last names combined. Okay, so this person's name was Justine Marcello. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This person's name had 15 letters. Another person's name had 11. Another person's name had 14, and 8, and 10, and 15. So this is the data that they recorded. So in part A it says, how can the data be organized? Describe one way to organize the data. Well, let's see. We could look through there and say, well, we got the number. I like to do things from least to greatest. So I'm going to look through there and say, I see an 8, and I've got one of those. I see a 9 right here, and I have one of those. I see a 10, and I have 1, 2 of those. I see an 11, I have 1, 2 of those. I see a 12, I have 1, 2, 3 of those. I see a 13, 1, 2 of those. I see a 14, I have 1, 2 of those. 15, there's 1, 2, 3 of those. 16 is 1, 2. 17, I see 1, I see 1. Are there any 18s? I don't see any. I'll put a 0 there. I see a 19. There's one of those. Okay, so there's 2, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have them all accounted for. Okay, so I've written down every number least to greatest and how many times. So this is the frequency number right here. This is the numbers in the chart, and this is the frequency, how many times they show up. Okay, so there's one way to organize it. Describe another way to organize it. Let's see. Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different numbers. So that's not, I couldn't group them because I couldn't group them evenly. These are called numerical ways to write it down. Could I also do it with tally marks? For example, the one that showed up 3 times. Could I do it with tally marks? 1, 2, 3. Could I do that? Sure I could. So it could be done with numbers or tally marks. With numbers, with tally marks. Tally. The word is tally, T-A-L-L-Y. These are tally marks. Okay? Compare the two ways, and what do you notice about the data each way? Well, it's just a different way of doing it. Gives you the same answer. And you're able to tell that the least one is 18, and the greatest ones are 12 and 15. They show up 3 times. Okay? So you can easily find the least and greatest either way. All right. Most importantly, let's answer this next question. What generalization can you make about the data set? Well, easily I can see 8 is the least and 19 is the greatest. And I can see the ones that showed up the most number of times is 12 and 15. So I can see the mode. So what generalization? The least and greatest are easy to see, and the modes are, let's see, 3s show up twice. Let's see. No, the mode, that shows up twice. So, I got lots of modes, don't I? So I probably wouldn't say that. I probably wouldn't put the modes down because there's just so many of them. Okay? It's easy to see the least and the greatest. Okay, turn your paper over. And let's get some definitions under our belt today. Mr. Maxwell timed the cross-country team in a 2-mile run and recorded the times in the table. He wants to analyze the runners' times. What is one way that Mr. Maxwell can organize the data? Well, let's see. Let's look at this table here a minute. We've got a 16. That's probably that's 16 minutes because it's a 2-mile. So this is 16 minutes and 45 seconds. Here's a 14-minute, 25 seconds. It's 18 minutes, 16, 15, 19. Okay, students, so it says, definition of a frequency table shows the number of times a value occurs in each category or interval. Okay, so as you can see here, they've grouped the running times that were in the 14 and 15 minutes together. And then it jumps to 16 to 17 minutes. And then it jumps from 18 minutes through 19 minutes. And then they counted them up. And there's 4 times it shows up here, 6 times here, and 2 times here. Now notice how you do tally marks. Tally marks, you do 1, 2, 3, 4, and your 5th one crosses those 4. So that if you have a whole bunch of tally marks, you can count them up easily. You can skip count by 5s and count those. So you need to understand things about tally marks. So that's why they did 1, 2, 3, 4, 5, and this one makes 6. Okay? Mr. Maxwell can set up time intervals for the data and then count the number or frequency of times for each interval. So that's what he did right here. And then it says he can use the frequency table to make a histogram. Okay, so these two things go together. We use frequency tables to make histograms. Now notice, a histogram we don't just have one number down here. We have a group of numbers that covers this bar. We have a group of numbers that cover that bar, and a group of numbers that cover that bar. And these are actually hooked together here. So from in the 14s and 15s, I had 4 of them. So my bar goes up like that. And then this goes to the 16 and 17 range. There were 6 of them, so this goes up there. And then there were 2, so this only goes up to the 2. The bars of a histogram always touch. Now, it looks like there's a little space in there, but there isn't. These should be touching. The side of this one, this right side of this one is part of the left side of this one. That little white space shouldn't actually be in there. Okay? All right, so let's look at one down here. Histograms are kind of fun, actually. Of course, as you know, I think all this math is fun. So, this histogram shows a different way to represent Mr. Maxwell's data. Fill in the boxes with appropriate times and shade the bars for the last 3 intervals. And how have the intervals changed? So if he went from 14, just did the 14-minute ones. Let's go back up here. He's doing them 1-minute intervals. So this would be 14 to 14:59, 15 to 15 and 59 seconds, 16 to 16 and 59 seconds, 17 to 17 minutes and 59 seconds. This is 18 to 18:59, and this is 19 to 19:59. Why are we just going to 59? Because the 60th second would make the next minute, which would roll it to here every time. Okay, so let's go up here and look. How many were in the 14s? And I'm going to make me a little table over here. How many were in the 14s? How many were in the 15s, the 16s, the 17s, the 18s, and the 19s? So we're going to go back up here and look. How many were in the 14s? There's 1, 2. So I'm going to come down here and put 2 tally marks. Let's check the 15s. 1, 2. 2 tally marks there. The 16s. 1, 2, 3. I see 3. 1, 2, 3. The 17s. 1, 2, 3. 1, 2, 3. The 18s. 1. Just 1. And the 19s. 1. Just 1 of those. Okay, now we're going to use our own tally marks. 14s it said was 2. They have that one done. That's correct. The 15s was 2. That one's done for us. The 16s was 3. That one's done for us. Now we got to do the 17. It's also 3. So we need to make this the same width, approximately, and a straight side. And that was the 17s. The 18s, there's 1, same width, and it goes 1 high. And the 19s, same width, and it goes 1 high. Okay? And slightly color that in. And I'm sorry, I put all of mine in the same box, and this one was done for me down here, and this one was supposed to be here, so there's nothing left to do right here. Okay, it says, how is the analysis of the information displayed different between the 2 histograms? All right, so how do these look different? It was grouped into 3 groups here. It's 6 groups here. So the display changed from 3 groups to 6 groups. But the data is the same. Same data in this picture as this picture. Now let's see how we can compare that. See this grouping right here? That's this one box here. See these two right here? That's this one here. And these two are this one here. It's just spread out a little differently. Neither one is more correct than the next one. Okay, example number 2. Zach surveys a group of middle school students and asks them how many texts they sent yesterday. The table shows the results. If we group them 0 to 19 texts, there were 5 people that sent text in that group. From 20 to 39, 4. From 40 to 59, 10. 60 to 79, 11. And 80 to 99, 8. So, part A says, is the greatest number of texts sent between 60 and 79? And the answer is yes. The greatest frequency is 11, which corresponds to the students who sent 60 to 79 texts. However, the greatest number of texts sent is this one. Okay? Is the lowest number of texts sent between 20 and 39? The lowest frequency is 4. And so it was between 20 and 30. You've got the lowest number of texts sent. This is frequency. This is sent. Okay? And so, however, the lowest number of texts sent is between 0 and 19. The lowest frequency is 4, which corresponds to students who sent 20 to 39 texts. However, the lowest number of texts sent is between 0 and 19. Okay, so let's see the difference in these questions. Is the greatest number of texts sent between 60 and 79? And that is true. Is the lowest number of texts sent between 20 and 39? The lowest number of texts sent is between 0 and 19. How many students, let's answer this question. How many students sent between 20 and 59 texts? 20 and 59 texts, that's 2. So we would have to add the 4 and the 10 together. So that would be 4 plus 10, and that would be 14. All right, let's look at example 3. The histogram shows the number of points that Kendra scored during each basketball game she played last season. How many games did Kendra play last season? Well, let's see. The total number of games can be found by adding the number of games shown by each bar. So this one represents 3. This one is 6. This one is 2. And this one is 1. So 3, there was 0 here. 3 plus 0 plus 6 plus 2 plus 1 adds up to 12. So Kendra played 12 games. Now, this is the type question you might see on a standardized test or your state test coming up before too long, where they give you a picture like this and ask you questions about it. Okay? In how many games did Kendra score from 5 to 9 points? How many games? There is no bar on the histogram for 5 to 9 points. So Kendra did not score 5 to 9 points in any game. So the answer is 0 games. Okay? And then the try it. Does the histogram show the mode of the number of points Kendra scored in the games? What do you think about that? Okay, so the answer would have to be no. Because since they're grouped, you can't see what number has been repeated. So, from a histogram, there is no way to see individual scores. So you can't tell the mode. All right, let's go to page 492. Key concept. This is like a summary of what you learned in today's lesson. The data displays can be used to help make sense of data. So here's a list of data. You can organize data into a frequency table. When we see we got 60s, 50s, 30s, 60s, 50s, 50s, 50s. Okay, so it goes from 30 to 60 something. So they chose to group it 30s, 40s, 50s, and 60s. Counted them up. We had 1 in the 30s, none in the 40s, 4 in the 50s, and 7 in the 60s. Okay? Then they were able to build their histogram. Now, I need you to notice something. Notice that our histograms don't start at 0, like normal tables or charts do. It starts with our first group. Our first group is 30 to 39, so it goes right here. But these increments coming up here have to be equal increments. And these increments have to be equal increments. They just don't start at 0 in the x direction. Okay? All right. Let's see here. How can a frequency table or histogram help you organize and analyze data? Well, we take data and break it into equal intervals. It breaks data into equal intervals. And shows with tally marks the frequency. Okay, number 2. How is a histogram different from a bar graph? Think about it a minute. I told you in just a little bit ago. The bars are in intervals. Intervals, not individual numbers. And the bars touch each other in a histogram. All right, number 3. What types of numerical data sets are easier to display using a histogram instead of a dot plot? Well, if you remember what a dot plot looks like, you have to show each individual data piece with a dot. So if you had a whole bunch of data, like 100 pieces of data, it would take you forever to do it this way. So when the data group is large. A histogram is better because you can group the data. When the data group is very large, a histogram is better. Okay, reasoning. How are frequency tables and histograms alike, and how are they different? Okay, let's see how they're alike. Well, they both are visual. They both show data. Both show data visually. Okay, so that's how they're alike. And then we're comparing frequency tables and histograms. Frequency tables use tally marks. Frequency tables use tally marks, where histograms put the same info into a graph. Both show data visually. Frequency tables use tally marks, and histograms put that same data into a graph form. All right, let's look at number 5. A data set contains ages ranging from 6 to 27. And they've got the frequency table built for you right here. So we're going to go through and count all the numbers that fall in this range from 6 to 10. Well, there's 1, 2. I see 2. So that's a frequency of 2. From 11 to 15, there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, from 16 to 20. 16 to 20, there is 1, 2, I see 2. From 21 to 25, there's 1, 2. And from 26 to 30, I see 1. Okay? Now, they want us to come down here and take that and make this histogram. So as you can see, the ages go down here. So this first blue line is going to be 6 to 10. The next one's going to be 11 to 15. Right small. 16 to 20. 21 to 25. 26 to 30. Now, there was 2, a frequency of 2. So this is going to be 2, 4, 6, 8, 10. No. It's going to be 1 through 5. 1 through 5. Let me fix this. You erase and let me fix it. Okay, sorry about that. So this is going to be 1, and they gave us lines right on. 1, 2, 3, 4, 5, 6. 5 is our biggest number, so our y-axis covers that. Okay, so from 6 to 10. And I'm going to come over here and use these little blue lines down here to find where I need to be. And 6 to 10 was 2, so I'm going to go up to 2. This one's at 2. 11 to 15 was 5, so I'm going to take this on up to 5 and find the middle of this. These should all be the same width. These should be the same width. From 16 to 20 is 2. And a ruler would really be good here. 21 to 25 is 2. And the last one is 1. Histograms are hooked together. There should not be any space between these intervals. Because as you can see, it goes from 10, jumps to 11, so it's the same line. Okay, now your job is to work on page 493 with your classroom teacher. This video is pretty long today. It's about 36 minutes long. So try to get at least page 493 done in class before you leave, or at least get a good start on it. And you'll have some more time tomorrow to work on this. All right, frequency tables and histograms. You should know what you're doing. I'll see you next time.